Okay, go ahead and pause the recording if you haven't read this word problem yet. But I'm going to jump right into it here. We're asked to find out how many adult admissions were collected. That's the bottom line. So how many adult tickets? How much money for the adult tickets that were sold? Oh, it looks like there's two types of tickets, adult tickets and child tickets. So I'm going to say A plus C. And if I skip all the dollar stuff, I see that there's something about the total amount of tickets. If I take the number of adult tickets plus the number of child tickets, that should make 2,200 tickets. Now I can't solve anything because I got an A and a C going on. They don't talk to each other. Not the same equation. So let's read on. Maybe we can make another equation and somehow combine these two like we've done in the other word problems. And let's make an equation based on the dollars now, because we're taking the adult tickets off to the side, making a separate equation. Now we're going to take the dollars and use that to help us make a separate equation. You can make equations with numbers as long as they're talking about the same units. Right? So $11 for every ticket A that's sold, right? So if there's 20 adult tickets, then $220. And then for child tickets, it's $6 for every child ticket. And that should equal the total amount of money they made. $17,200 in admissions were made. Right? So the money from adult tickets plus the money from child tickets, this should equal the total amount of money they earned. It might look hopeless still. We don't have anything we can plug in like we did in the other equations, but let's take this guy off to the side real quick and just do one little algebra step. And I bet you'll be able to see what I did here. But I'll explain if not. I took this equation and I said I want to know what just one letter is. That way I can plug it into my other equation. And that's easy to get A by itself. We just have to subtract C from both sides of the equal sign. Right? So this is what this equation looks like. Let's forget about that guy up top because we have something that says the same thing. It's right here in red. And the whole reason I wanted that is because I'm trying to solve this problem where I have two different letters in my equation. If I plug this in for A, then I only have the letter C going on. And now I have an equation to solve. So using the steps that we talked about, when you plug things in math, just a little side note, it couldn't hurt, could help to use parentheses. So use a parentheses around there. Now I can distribute. But you thought you'd never see that property again in a real world setting. 24,200. And distribute to 11. Getting closer. These two are both in terms of C. So we can do a negative 11C plus 6C. That makes negative 5C. And then trying to get C by itself, we could subtract 24,200 from both sides. And that leaves us, don't forget that negative sign that's out in front of that 5C. That's negative 5C equals, we got 17,200 subtracted by 24,200. Makes negative 7,000 over here. So the last step is to get C by itself. Well, that's been the whole steps all along, right? I think I'm just saying things that math teachers say for no reason here. The last step to get C by itself is to divide negative 5 from both sides. So I got negative 7,000 divided by negative 5. Negative divided by negative makes a positive. So there's 1,400 child tickets. Okay. All this stuff here, if you just skipped ahead in the video, this is just the algebra. Okay. You'll want to focus carefully on what we did in order to get to this point. We made two equations. And then we rearranged one of the equations so that we could pop it into the other equation. But if the question's asking for the number of adult tickets, that's easy. There's 2,200 tickets total. 1,400 were child tickets. So if you subtract those two, that means there's 800 left for adult tickets.